Hi, I'm in McKinney, Texas. Thought I'd share with you a conversation I had 2 weeks ago, and actually continuing from a year ago. I was involved in a review on how to rewrite an existing financial business application, a deposit system for a large bank in an area of the world. And it's a very old system. The team might be the second or third generation of people that have been trained up on this system, and we're asking how they attack renewing and revitalizing it. It still has code that's running in production, IBM Z mainframe. The code originated as a vendor product in the 1960s. In the early 80s, the vendor went out of business and the company bought the source code and took it over maintenance themselves. There are sections of the code that have products listed that are no longer products that exist or are executable. Yet you can see that the code has the function calls to call these products. Obviously, that section of code is branched around and isn't ever executed, but trying to determine what the execution path is through the code is difficult. The code has no separation of infrastructure functions, such as teleprocessing, monitoring, and file management and database management sort of functions. It's all intermixed because of the age of the system. The question from the team to me was, how do we go attack this system? How do we rewrite it? How do we replace all this business functionality that exists within this package today? The system has to be built upon tabulating system principles because of its age. One of the principles you note in the system is that every day, at a particular time in the day, it has to do with batch update, its posting process. Posting processes will take the transactions from the day and update and create a balance, so eliminating the volumes of all the transactions from history. And so that means that the online system is turned off for that period of time. It stops processing. And any online transactions that occur during that, it's going to be in the middle of the night, so there's few online transactions. All of those are queued to be applied to the system after the system comes back online. That's one key synchronization point, is that you know that at the end of that posting process, the database is made in a consistent state. The second synchronization point, though, is that after the online posting, after the nightly batch posting is done, they run another set of programs, a batch set of programs that take all of the queued transactions that have piled up during the posting process and stick those into the database. Focusing on that batch process that executes the transactions that have piled up during the posting process is a key set of code. What's in that code is update functions, and it's compact code. It doesn't have to deal with any of the messaging and queuing and all of the problems of the online transaction system. It's very pure business logic that does the most critical function, which is the update function. It doesn't do things like query for inquiry processes and messaging to other systems. That's not needed. But those update functions are some of the most difficult to determine exactly what they mean and how to reproduce them. What you have to get to is that you have to get to the knowledge of the people that wrote the original code in order to go recreate the code. You have to have all of the understanding they had when they put each one of those functions in incrementally over time has to be embedded in people's heads. Sometimes people think that that's a bunch of documentation, but the document involved really is the code that exists. That is the document. It's fortunate that this code, this document, by its nature as a computer program, can be executed. It can be run. You can look at the files after they've run these processes and determine what changed. You can see the results of the document being run. We'll go through these a little bit more detailed, and let me talk you through in some slides what this means.
First, let's give an overall view to a typical large banking system environment and what the processing cycle looks like for the daily financial cycle, as I've called it in other videos. Most of the day is taken up with online transaction processing. beginning perhaps at 8 a.m. and closing off perhaps at 11 p.m. The night is filled with typically these kinds of things. First, there is a detailed customer posting process. Second, there's a second phase of inter-system processes or other things that clean up from the detailed customer posting. The last thing that happens in the middle of the night is the general ledger posting, and then there's typically a small space of window that's safety in order to make sure that the daily financial cycle is completed on time every day. Let's drill into these two processes more deeply. As the system is built on tabulating principles, these parts of the system may be the oldest parts of the system and the most important parts for starting an analysis to come to understand what the basic principles behind the system is. During the detailed customer posting, transactions that have accumulated through the day but have not yet updated the customer balances are applied to customer balances. So this then will allow us to eliminate these transactions from history, speeding up the online transaction system by dealing with only the balance as of the day before at the end of the posting process. While this work is going on, there's a clear cutoff of any transactions as that process begins to make sure that we have everything in control and balance. So all of the transactions that come on after the moment that that process begins are queued and held to be processed at the completion of the posting process. The last step in the detailed customer posting process is to do a control process which checks to make sure that all of the transactions that have been accumulated from the prior day's period have been appropriately posted and updated the balances, and the database is left in a completely stable, steady state. So the test of that process is to sum the daily transactions across some set of keys and make sure that they're equal to the change in the customer balances from that same set of processes. In order to connect to a lot of my other videos, it may be helpful for you to understand that at that same time, typically, the general ledger feeds are created as well, whereby the daily activity of customers is summarized to make journal entries, and often a control balance record is made stating what the total balances across all customers are for that same point in time. The last step in the process is that once the transactions have been posted and everything is left in the balance position, then the transactions can either be archived or marked as posted. This means in the next day's process, transactions don't need to be used because the balance reflects that activity. This is the key point that we've been talking about in this video. Once the daily posting process is complete, then the transactions that have been queued need to be applied into the database. There is a particular set of programs, typically a batch application, that will apply those transactions into the database. And all the business logic in there is a concentrated kind of business logic dealing with the update cycle for how to apply transactions to the database. By analyzing the impact of that batch process and particular kinds of transactions into the database, one can begin to build up a knowledge of how the database changes for particular types of database transactions. This application can be run over and over again for different kinds of transactions, and the database impacts can be isolated, tracked, and understood. Through this process, one can then begin to build up a transaction update heat map, whereby each transaction type and the fields that are affected by that transaction type in the update cycle can be understood, clarified, and known. This then becomes a process whereby all of that accumulated knowledge of building the system over all of those decades and the changes and updates that have been made to it can be captured in and understood by people developing the system. This process also becomes the possibility for starting to break down how you go change the system by identifying types of transactions that have similar types of update patterns, by starting to identify pieces of the database that can be isolated and updated to new values, and where the integration point is upon which transaction or in the daily customer update cycle where it needs to be integrated back into the other database.
As I talk to people about these kinds of systems, I sometimes find a lot of disparaging remarks about spaghetti code. I don't think that's appropriate. These legacy systems are really tremendous systems. They deserve a lot of our respect in terms of the people that originally built them and the longevity of the system, the efficiency with which they do what they're supposed to do, the great accuracy that is built into the system. Attacking or rebuilding one of these systems is not a job for the faint-hearted. If we were to be able to be one of the early pioneers of automating systems, it would have taken great courage to be able to think that we can make them accurate and do all the things they do today. It requires similar courage of us to think that we can go rebuild these systems. It's not the same challenge that they had because they didn't know the road before them when they originally built these systems. But these systems provide us a great roadmap to follow in rebuilding them and refreshing them and renewing them. So it's a different kind of problem than what they faced, one that might be as daunting in some respects as what they faced, but it's different. It can be done. It takes courage. It takes respect for the system. It takes intelligence about how they built the system and understanding how the system worked for those that constructed them originally. But it certainly can be done, and it's very rewarding to do so.